Hello, in this video we will learn how this differentiation of sin x comes as cos x. How this sin x changes into cos x on differentiation we will just learn now. For this we should know few things. We take it for granted. Three things, or we assume we all know it. What are the three things which we should know to understand this? You should know the definition of differentiation, without which you can't proceed, because you are finding differentiation of sin x, so you should know the definition of differentiation. Then you should use one trigonometric formula, sin c minus sin d formula. That is the product formula which we have to use it here. Third one is again the limit concept, limit theta tending to 0, sin theta by theta equal to 1. We will have to use all those three in the differentiation of sin x. Okay, so I just list them here. First, the differentiation definition. F of x is equal to limit h tending to 0 minus fx by h. This is the definition of differentiation of a function f of x. The definition says limit h tending to 0 f of x plus h minus f of x by h. You will have to evaluate the limit. What is h here? Is small increment in the value of x. Okay. When you make this h, or when h tends to 0, when you evaluate this limit, what you get will be differentiation of f of x. But for this differentiation process, we will be using sin c minus sin d formula. Sin c minus sin d, 2 cos c plus d by 2 into sin c minus d by 2. Right? Third one is about the limit, which I already told you, limit theta tending to 0, sin theta by theta to 1. Of course, here theta should be in radian. Okay. So all these three we will employ here to do this differentiation from first principles. Okay, right. Here f of x is nothing but sin x. Differentiation of f of x we are taking up as per this. For that, f of x is sin x. Therefore, by definition, by h. Okay, right. Now what would be this f of x plus h? It will be sin, f of x is sin x, you know, so f of x plus h will be sin x plus h. Of course, this will be sin x. Okay, proceeding further. We finished this next step. Now this is of the form sin c minus sin d. The whole thing here, you know, that you can take as c. C is x plus h. D is this x. So use this formula, sin c minus sin d. 2 cos c plus d by 2 sin c minus d by 2. So by 2 whole divided by h. Okay. Now how did you get this? See, 2 cos c plus d by 2. These two we have written here. Cos c plus d by 2. C is this. D is this. C plus d. X plus h plus x by 2. Sin c minus d by 2. X plus h minus x by 2. This is a plus x and this is minus x. Of course, this x, this minus x, you know, you can cancel. Okay, next. Sin h by 2 whole divided by h. So we have not yet evaluated the limit. We can't evaluate the limit at this juncture because when you put h as 0, it becomes meaningless. Divided by infinity will come. So divided by 0 will come. That is not allowed in evaluating the limit. Okay. You can't directly now substitute h as 0. That all comes in the evaluation of limits. Okay. Now this 2 you can bring it down here, and also this 2x plus h by 2 you can write as x plus h by 2. Okay. So what we have done, we have taken this 2 and brought it down here in the denominator of the denominator. That is allowed. Now you have to evaluate the limit. Now we are in the safe level. You can evaluate the limit. But you know this is cos x plus h by 2 sin h by 2 h by 2 divide by h by 2 sin h by 2 by h by 2. You can write this as limit h as 0, limit h tends to 0, cos x plus h by 2, again limit h tends to 0, sin h by 2 by h by 2, using the property of limits. Right? So this limit should be applied individually to these two things because they are forming the product here. You can just say this limit is applied for this, and also this limit is applied for this. Okay, for this. Right. Limit now you see actually it is limit h tending to 0 we should put, but because of this format, you know, sin h by 2 divide by h by 2, and this can also be written like this, h by 2 tending to 0, because when h tends to 0, h by 2 also will tend to 0. So change it into h by 2 tending to 0 so that it will be in this form. So you can write it as 1 easily. And here you can substitute h as 0 because the function survives. At this juncture you can put x as 0. You should not put x as 0 in the previous step here. Here you should not put, but here you can put. For the simple reason that if you put h is equal to 0, the function exists, survives. So you can substitute here. You can't substitute here h as 0 because h tends to 0. Here you can put h as 0, so you will have cos x. For the whole thing, the limit is 1. Okay, 1. Using this property, third one which I have listed there now, using that. This would be cos x. Actually cos x into 1, which is cos x. Understood? Thank you.